All right, good day, everyone. Welcome to another section with Victoria. Yeah, I'm the teacher of Hydrogeological Hub, and of course, I want to welcome you. We've paused for a very long time, and our classes hasn't been moving straight that's because of my busy schedule during my NYT. So once again, welcome and I sincerely apologize for the break in transmission. All right, so we're gonna kickstart in NS and this time around we're gonna be having our classes back to back, okay? All right, so once again, thank you to all that sent their wishes. I'm truly grateful. All right, so we stopped and we're gonna continue from creating and or designing our dashboard, interactive dashboard in Excel. All right, so before I kickstart, so we'll just continue from any. But before then, let me just quickly let me share my screen. Good. All right, so this is what we're going to be looking at today. All right, so all you need to know about creating a hydrological dashboard. Of course, there are different organizations who works with different purpose and for their brands and whatever. But because of Hydrogeological Hub, our brand is known for hydrological studies, right? So we're going to be creating an interactive dashboard using Microsoft Excel. So a step-by-step guide by Hydrogeological Hub, right? So introduction to the dashboard. So before we kickstart, you need to understand what dashboard is: a visual display of key metrics, not everything, the entirety of the data set, just key metrics and data trends. So use for quick insight and decision making. You use it to get insight of what the data entails and what it looks like, and then make or proper decisions after you've gotten a generated insight. So Excel dashboards can include charts, tables, slicers, timelines, and the rest, okay? All right, so objective of this class is you're going to learn how to create hydrological dashboards using Excel, of course, not just creating the dashboard, but interactive one. So use sample data related to boreholes across Nigeria and gain hands-on skills with charts, filters, and interactivity. Now, understanding the data sets. First of all, I always tell people that you need to have your domain knowledge for you to generate. And you don't just want to wake up one morning and then you just want to design a dashboard. First of all, what problem do you want to solve? What are you driving at? Okay, so what are the problems you want to solve? Right, so where in Nigeria is groundwater quality not threatened? And the rest, okay? So what are your key variables? How do you want to do it? And the rest. So we're going to be treating all this. So now let's go to the step-by-step process. Now, one, you need to load and clean the data. Insert pivot tables for summaries, create pivot charts, add slices and timelines, arrange components on the dashboard sheet. Now, tips for effective dashboard: use clear labels and titles, highlight key metrics, keep visual samples and unclustered, ensure sliders work across all charts, okay? So we are going to be doing that step by step now. So I'm going to be opening my Excel worksheet. I would love to have a clean data set. So just a new data worksheet. So this is my new worksheet. Let me save just how do I save it to it? Okay. Hydrogeological dashboard. All right, so yeah, so this is it. It's a clean worksheet. Now we're gonna load our data. So mind you, I'm using Microsoft 2013. My 365 actually subscription has ended. So, and I don't have 2016, so I'm going to make use of what I have. Okay. So take note, you might be having 2016 and or 2020, or probably there are some steps we want to carry out, which you necessarily don't need to do this. That's using Power Queries, right? So, but we're going to be treating that in our next class in Power BI. You're going to be seeing how to do the Power Query on Power BI, okay? So, but notwithstanding, I'm going to make do of what I have and also create my dashboard. That is one. If you know me very well, you know that giving up is not just my thing. I'm going to do it, okay? It might be hard, but I'm going to do it. All right, so course, this is my home tab. So you go to your data tab and then you open your from you click on the front text ribbon there. Then you load your data sets. Okay, so my data set has already been stored on my download. So I'm going to click on it. Now, immediately I click on it, this is what pops out. Okay, so now please take note and see what I'm actually clicking on. So I'm dragging this ribbon down to the very last. Okay, now you see. Now I move gently up until where I get to see 65001 Unicode. I click on it. Okay, then I click on next. Remember to click on your comma. Once you see that the data set I was looking, okay, the data set I was looking like the data that was gathered from the space or something that's looking solitary and everything like the text or sentence. Now once you click on comma, it helps to, it's now making it look sensible, right? It's not looking like a table that has column and rows, okay? Now you click on next and then you click on finish. Uh okay, I'm gonna click on new sheet. Now, see it has generated the data set and it's looking more clean and well organized or structured. Okay. Now, this is it. Why I did this is to ensure that our data is well structured and aligned properly. Okay. And it's clean and well arranged. Because once you get the data set from, okay, I think I have the data set opened. This is what it looks like when you just open the data set directly. Okay. It's looking a kind of bit messy. So what this helps you do is it helps arrange it properly now. So we start doing the necessary thing. Now, the next thing is for you to understand the data set. What are the key variables on your data set? Okay, so what are the key variables you're having? Now you have on that we have state, we have location, we have borehole ID, we have date, we have water table depth, we have pH, we have nitrates, I have iron, we have West Tetros population south season. Okay, so now you need to know your categorical data and your numerical data. Categorical data that of course, you know what categorical data now. So it includes our state, our location, our seasons, right? So those ones I don't have to do with numbers. Okay, what that those the ones I don't have data and numbers on them. Okay. Now, so your numerical data has your pH, your nitrates, your water table depth, those one that has numbers inclusive. Now, then the time. The time means the date, the year, the month. Okay. Now, looking at this, I want to do something because I'll be making use of my dates and yes, because I want to generate an answer and of course I want to know the trends that occurs yearly, that occurs monthly, and of course, yeah. Now, so I'm gonna have a separate column where I'm gonna insert another column. Okay, so and I'm gonna call this, oh sorry, okay, just do something now, paste it here. So I'll have the year here. So I'm gonna call my header year. Now in this year, I'm gonna extract the year from the time or the date. Now I'm gonna put equals to year is a function already, an inbuilt function already on Excel. That's the same. See, it has extracted the year for me. And then I will just double click on this extreme end here, and then the whole thing generates automatically, right? So now let's see how we can do this for our month. We want to know our month. I will just click on this window. We go. Insert entire row. All right, so I'm going to call this month. As I want to extract the month, I will just click on equals to, because I want the month to be in text, as text, right? So it's definitely going to be in text. So the value, like this, I'm clicking on this, then comma, What's going on? First to format. So format text. I'm gonna put. Remember, your text is string. Our strings are always in quotation, right? Or your texts are always in quotation because now of course, the computer understands zero and one. So for text, you're gonna put it in your column M, and then I'll close it. Yeah, so of course, shift is me. So let's see how to extract it. We'll double click on it and perfect. Okay, so we've gotten a pH, and when you say when you talk about water depth, we have shallow aquifer, and then you have deeper aquifers, right? So shallow aquifers are aquifers that are close to the subsurface, right? So yes, so they're not deep enough. Okay, and you know what that means when you have shallow aquifer, know that the water quality is prone to contamination, right? So the deeper the aquifer, the deeper the safer it is for water to be consumed by humans, right? So shallow aquifers actually not really safe because penetration of contaminants can easily penetrate and therefore contaminating those aquifers, right? Now, pH, of course, when you look at the pH, so these are samples that are gotten, mind you. So these are samples or analysis that have been done on those different boreholes, okay? So because this pH is telling you that, okay, these are water quality tests. Your pH, the nitrate content, the iron content in the water, right? So for your pH, it's, of course, based on what health standard, anything less than than 5 is really not, mhm, that it's not safe. So from 6, 7, 8, it's safe. Then anything above 8 is actually is still not good for consumption. Okay. So your nitrates, your iron, and well status. All right. So of course, season, rainy season, um, rainy season, dry season, rainy season, dry season. I can choose to create another function here where I want to know the wells that are okay. So well status active, seasonal, active, seasonal. Okay, but since I have well status here, the well status is telling me that okay, it's active in such a way that in the year 2023 is active. This well is active. It always gives water. And the season is during the rainy season. During the rainy season, the well is always active and it generates there's flow or there's a huge amount of water in the aquifer, right? So it's active and the population consumption is about 4,000. That's a good one because people come to consume the water. People come to extract water from that particular well, borehole, and the amount of people that comes is around 4,837. So now, but one thing is active. Mm, mm. But what do you think? Shouldn't we add I'm thinking of we adding something else, like the water quality based on is it safe? Is it safe? Unsafe? Safe. Based on the pH value, nitrate, and ion content in the water. So we want to generate something. Is it safe? Is it safe at all? Is it safe? Okay, I'm trying to look at something. All right, so So these are water depth, pH, and everything now. So we're gonna start away now. The next thing to do is we are going to change this to, I want to convert this to become a table before you generate your pivot tables, right? So now just what you do is Control A, select all, and short form, you just press Control T on your keyboard, and then, yes, my table has headers. Yes, this header means date, location, borehole, date, month, year, water table, blah, blah, blah. These are our headers, okay? Now, and then you click OK. Yes, just it. So it has carefully, beautifully generated a table for us, right? So when you mean table means it has a drop down list of items, okay? Beautiful. Now, or better still, if you don't want to do the Control A, Control T, you can just go to Insert. When you click on Insert, you click on Table, and then does the same thing, okay? Now, once we are done, the next thing that we are going to do is to generate our pivot. Okay, let's go back to our slide and see what it has for us. You see, insert pivot tables for summaries. Now, perfect. So now this is what we are going to do. But one thing I always tell people is the domain knowledge, understanding your data set. What do you want to solve? What problem do you want to solve? Right? So what is the problem? We want to solve the problem. What problem do you want to solve? Okay. Where in Nigeria is groundwater quality most threatened? Which states have high nitrates or iron? We want to know the state that has the high level of nitrate, and we want to know seasonal or regional patterns in water table depth. Right, so what proportion of well are active or inactive, and how does the water quality relate to population sat? Right, okay. Mm. But I'm thinking something, yes, I was thinking, should we use an if function that will tell us when this particular depth of water has this so amount of pH and so amount of pH, it should be okay, good for consumption. If it's anything less than this, nitrates, blah blah blah, is not good for consumption, and the rest, something like that. I'm just trying to think. Yeah, let's do something. Let's do something. Hmm, I've done something. So I want to call this water quality. As I want to give it another table. So the water quality based on, so but before then, let's know our World Health Organization standard for pH level in water, in nitrate, in iron. Hmm, okay, let me see if I could Google something. And stop sharing and see if I could Google something. I want to get, let's find out for pH. We have pH, we have nitrate, we have iron. The key parameters, right? So when the water is acidic, So just note this that all right, so just note this that pH acidic water health standard, pH standard or water health standard is 65 to 85 acceptable range. That is, yes, it's safe, right, for drinking. And for nitrates, it's the maximum allowable concentration is 50, right, milligram per liter, right? So the high nitrate levels are especially dangerous for infants. Please note that. Okay. So iron, it whose aesthetic guidelines is 0.3 milligram per liter. Okay. So we are going to use this to generate. All right. So, uh, so I was thinking out loud, right? So since we have our values for pH, nitrates, iron, status, right? So I was thinking, I want us to know the water quality. Is it safe for drinking for each of the borehole samples, right? So we want to know. So I think an if function can give us something, right? So based on World Health Standard, I browsed about the World Health Standard for pH, for nitrate, for iron content in water. And let's see what it gives us. Okay, we have something like this. All right, so okay. Now the pH value for that is acceptable by World Health Standard is 6.5 to 8.5. That is safe when you do your test or your analysis and you're trying to know the pH value for the sample. It's if it ranges between 6.5 to 8.5, then it's very much safe for consumption. Then if corrosiveness test is so for nitrate, it's lesser than equal to 50, and then for iron, lesser than equal to 0.3 milligram. Okay, let's see how it goes. Okay, so let's see how to generate. I'm going to use an if function here. All right, so we have so let's put an if function equals to if mhm, logic test. We're going to use and if logic one. Okay, if this a pH value, so I highlighted everything there. Okay. Mhm. If that is if is greater than, I don't know what we have, is greater than equal to greater than equal to 6.5, 6, 6.5, comma, the same, remember there are two values. If it's greater than or lesser than equal to now, lesser than equal to 8.5, comma, okay, we don't have a pH, so let's go for nitrate. If it's greater than equal to 50, sorry, lesser than or equal to 50, beg your pardon, comma, remember the word has standard value, right? Then see for iron, we have, if it's right, 0.3, so if it's lesser than equal to 0.3, so let's pass our argument for each of them. So if it's lesser than equal to, for this value, it should be safe. If it passes this, requirement, then it's safe. Safe. Safe for consumption, safe for use. If it doesn't pass it, then it's unsafe for use. See what's happening, people of God. People of God. It's unsafe. Oh, yes, because this pH value is the water depth. What do you think? Okay, so we are going to go straight up now to generate our pivot table or pivot table. So you click on Insert, click on Pivot Table. So we're going to click on New, it's already on New Sheet, and click OK. Perfect. So now it has taken us to this is a new sheet. So permit me to call this is our original data. So let me call this data sets. Data set, and this is actually blank. I'm going to leave it here for my. So let me call this pivot table one. So I'm going to use PT1. So you see pivot T1, I mean pivot table, right? So I'm going to drag it here. And then, right, so now, we want to know, we want to create a pivot table. So our pivot table will enable us to generate our pivot charts. Okay, and it helps to link up the different variables together. Okay, so we have average water depth. So we want to know our average water depth. We want to know our average water depth by state and seasons, right? So we want to know the average water depth for each of the states. Okay, and because this average water depth is numerical data, right? So and then again different samples. So it is you normally you would have said, okay, why don't we know the sum? But average gives us a cumulative um it gives us a proper prescription or proper prediction, okay? So we get to know the average, know what average means now. You get the total sum and then you divide it by two. Because if you want to get the sum, some data will be looking so average or some states will be having higher values. So in order to contain all this, we're going to go with average, right? So we have states. I'll click on state. My state because script data is going to rows, right? And then location. Each of the boreholes has different locations. So I will take this to the column and then the average value. So remember, we're trying to generate our average value water table depth by state. Water table depth. So we're going to know the average water table depth. This is water table depth. Now look at something. Normally, when I click it, it's going to give me the sum total for each of the various entries that were made for the water depth for each of the borehole locations, right? But I want to know the average, so I'll click on the drop down arrow here, and I will click on value field settings, and I'll click on average. So we're going to do that in the next one so you understand better. So that's giving us the average value for each of them. By state and season. So I'm trying to know the average water depth by state and then by the season. Instead of, yeah, instead I'll use, Hmm, this is I love labeling mining, so I don't get to. I know what each of every table entails, right? So I'm going to call this average water depth by state and season. Okay, and so we've gotten that. So we are going to be looking at another pivot table. So for me, I will just copy. Okay, I will just press Control, copy, have extra. Right, so actually this is I'm going to erase. Let me go. So instead of going to create an area to do this, I just copy and paste the initial one I have then. Yeah, I'll check all of them. And the next we are going to be looking at, we want to see its pivot table. And the pivot table is us to know in each of the states, we want to know the level of or the amount of pH content, nitrate content, and iron content in each of the water samples, right? Or the borehole samples. So now we want to know the pH content. I want to know the pH, the nitrates, iron, and iron level. So I call it level of content amounts in the water, in the borehole sample, in the boreholes by states. So in each of the states, let's know the amount of um so click on this, it helps us. So by state, definitely we are doing it by state. So this goes by states, and then water, iron. So please check, remember to put this in average, please. Want to know the amount, the pH content amount in the boreholes by states. Let's filter by season. I think I want to work with by year. The year, the month. digitize. Let me try now. Copy this again. So uncheck all. So then the next one I want to know is number of boreholes. Okay. Now, I want to know the number of boreholes per well served. When we have wells served, like we had, let's look at the data set. We have population served, the amount of people that draws from this well or that consume from the population, the number of people that served in this well that consume from this well. Now, show this. Okay. Now we want to know the. Okay, I'm gonna change this to number of boreholes per well status. Okay. Now we want to know number of wells. So we have well status. Okay, and then count of borehole ID. Remember, you have to know your categorical and then this is numerical data. Okay. So count of number of boreholes that are active. It's Naira 83, Naira 86 now. The one that is either active or not really active or frequent. Then I'm gonna if it tied by state, by season. Wait, number of problems. Okay. Let's duplicate this again. So I'm gonna change this to population served. I'm gonna uncheck population served by state. I'm gonna use state. Population served by state. Okay, so this state is coming down to rows. So population served. So we have a population. The population that consumes each state, the total amount of population that consumes each of the boreholes, right? Yeah. Okay. So I want to look at contaminant trends over time. Mm, Served by states that are contaminated. Mm. I was thinking something now. Sorry, let me do something here. Population served by state, right? The numbers of people that come to draw for it by state that are contaminated. That's let me say water. I'm doing. Mm, mm. Now, I'm trying to generate something, right? So, this will not draw the attention of the health sector and say, okay, if we have we have the population that consumes, yeah, about 18,357. Sorry, 183,527 people consume a particular borehole in the whole of Abia State, right? So now in that, people that are say people that draws from that well or consume that well, that okay, they are not prone to any sickness, is about 12,703. That's the same. About 170,884 are consuming water that are not safe based on World Health Standard. Hmm. What are you thinking? There's a problem. Big time. All right, so we're just trying to generate analysis. Okay. This is just an analysis, okay? And data generated. Okay. So there's no cause for alarm yet until mind you please, this data set is kind of generated, so the authenticity of this data set is not well known. Okay, so it's not actually something that we should get panicked. Okay, so after we've known that, all right, so I want us to look at contaminants. Contaminant trend over time. Mind you, let me uncheck this place. Okay, I'll still need year. I'll still need month. Um, okay, when you're talking about contaminant, definitely you're looking at the pH value. Mm-mm. Yeah, quite average of year. No, where's that one coming from? No, yeah. Okay. Let's look at location like contamination, top 10 location by contaminant. So we want to identify places that are prone to contamination. These are hotspots, right? So that needs key attention. We'll check out those places. So I want to sort this, right? So we are looking for top 10. So I want to sort this. I'll click on A to Z. Oh, okay, top 10. Descending. So being able to get all of this to Alright, so now we are done with have about 6 charts. As we'll be generating about 6 charts. So we're done with your pivot table. So we'll now go to insert. Then we'll click on insert pivot charts. Then let's say our next, let's go to this 4.2. The next step is create pivot chart. What's the name of this? Average water depth by state. Alright, so I want to do, I don't want all to station. I want to, you see where you see analyze, right? Um, I want to give this a title or chat. I'm going to copy this. No, yeah, hide all feed buttons on chat. Perfect. So let's generate the next one. Click on analyze. So, so want to include commented private chat. Mm. I'm using a stacked column. Let's see. Go to design. I want to add a chat title. So you just go to design and click on that. So I'll just copy this. to title it. So it's going to give me really tight. So that's let's go to design. Chart type 2 above chart. Okay, paste.